shape.
It looks a little fuzzy. It doesn't have the same kind of bright central concentration that you would see in a normal galaxy. It has very peculiar colors. And all of these things seem to be tied to this collision between M81 and M82.
Studying galactic collisions is like sifting through the evidence of a crime scene. The smallest detail can help determine when the crime occurred. In the case of M82, astronomers have been trying to piece together the collision and find out how long ago it really happened. O'Connell and his team dated M82's crash by examining the star clusters that formed afterward. The dense star clusters form as gas clouds from the colliding galaxies interact. O'Connell's team is seeing the types of clusters that may have been common in the early universe.
The initial formation phase of galaxies is a very violent
For the Hubble
process.
Deep Field, it was important that we get a essentially unblocked view of the distant universe. We want it to be unblocked by anything in our own galaxy, that is bright stars or dust in our galaxy. We wanted to avoid any bright nearby galaxies that might have essentially dominated the picture. And so we had to do some studies to find a field of sky that was essentially boring in every way so that we could look at the distant galaxies.
The team targeted Hubble's continuous viewing zone, narrow patches of sky near the north and south poles, where Hubble can stare for several days without being blocked by the Earth. The long exposure brings out wispy detail in galaxies as far as 12 billion light-years away, but the telescope also captures light that astronomers need to filter out.
The problem is that the telescope itself is subject to radiation from charged particles, most of which come from the solar wind.